Okay, so 3.4, we're going to talk about exponential and logarithmic equations and inequalities. And so we're going to solve exponential equations, we're going to solve applied problems involving exponential equations, solve log equations, use the logistic growth model, and use logarithmic and exponential inequalities. All right, so let's go ahead and just jump into example 1. So in example 1, it tells us to solve. And A tells us 25 to the x equals 125. Well, remember, the easiest way to solve exponentials like this is if you can get like bases. So can I take 25 and 125 and go down to the same base? Typically, I actually ask myself first, can 125 go down to a base of 25? And the answer is no. So then I say, okay, well, can they both go down to some base? And yes, they both have a base of 5. So 25 is 5 squared to the x, and 125 is 5 cubed. And then right here on the left, we have power to a power. So it's 5 to the 2x equals 5 cubed. The one-to-one property says we can get rid of the bases because they're equal. Therefore, 2x has to equal 3. Divide both sides by that 2. And we see that x is equal to 3/2. B wants us to take 9 to the x and set it equal to 3 to the x plus 1. And we're going to solve for x. Now, my bases are 9 and 3, so can I take 9 down to a base of 3? Yes, 9 is the same thing as 3 squared. And then I have to the x equals, and I don't have to do anything to the other side because now they're going to have like bases. On the left side, we got power to a power, so that's 3 to the 2x equals 3 to the x plus 1. The one-to-one property says our bases are equal, so we can get rid of them or ignore them. And then, so which means because our exponents have to be equal, so 2x has to equal x plus 1, and then just solve for x. So I'm going to subtract the x over, and I get x equals 1. All right, and so what we see there is if we can solve these exponential equations by getting like bases, it's really pretty easy. But what if we can't? And so we can use logarithms to help us solve them. So we're going to solve exponential, and I'm just going to kind of abbreviate some here, equations using logs. All right, so our directions to do this is step 1. We're going to isolate the exponential expression on one side of the equation. So isolate exponential expression on one side of the equation. All right, step 2 is going to be to take the common or the natural log of both sides. So we're going to take the log of both sides. Now, it says we can take the common or the natural log, but guys, I'm going to go ahead and give you a heads up. If it's base E, you have to take the natural log. And MyMathLab wants you to use natural log all the time. So that's what I'm going to go ahead and do here. But it really doesn't matter if you take the natural log or you take the common log unless it's base E. But I'm going to go ahead and use natural log each time because that's what MyMathLab is going to want you to do. All right, so we're going to take the log of both. I didn't finish that, sorry. Sides. And step 3, it says we're going to use the power rule. So that's where we have log base b of m to the r. And we said that's equal to r times log base b of m. And then we're going to step 4 says solve for the variable. All right, so there's our steps. Yay. And let's go ahead and let's try them out. So if you need just to write these down, go ahead and pause the video so you can do it because I'm going to erase them and move on. All right, so for example, we're on 2. Our directions are to solve. We're going to solve for x. So they gave us 5 times 2 raised to the x minus 3 equals 17. Well, I can't just get like bases because I got that 5 times 2 to the exponent. So we're going to work to get that exponential part there by itself. So we need to get this by itself. So we got to get rid of the 5. And since it's 5 times, we know to get rid of it, we do the opposite. So we're going to divide by 5. So 2 to the x minus 3 equals 17 divided by 5. You can leave it as 17/5, or it is a nice neat decimal. So I'm just going to change it to that. Alright, so that was step 1. We isolated the exponential expression on one side of the equation. Step 2 says take the common or natural log of both sides. So we're going to log both sides. So I'm going to use the natural log. Remember, as long as you do it to both sides, it's okay. And so step 3 then says to use the power rule. So that's where we're going to take this exponent and we're going to move it in front of its log. But be careful because that exponent was together. So you have to show that that x minus 3 is still together. So put it in parentheses. So you have x minus 3 times the natural log of 2 equals the natural log of 3.4. And now we're just going to solve for x. So it's up to you. You could distribute the natural log of 2, but I'm going to go ahead and just move it over. So I'm going to divide both sides by the natural log of 2. And when I do that, I get x minus 3 equals, and you could put that in your calculator and get a decimal. I'm just going to keep it for now. And then we're still solving for x, so we're going to add the 3. 3 doesn't have a log, so it's just going to go there at the end. Alright, so I'm going to, because I'm out of room, bring this up here. And so we have x, the 3 canceled, so equals, we have the natural log of 3.4 over the natural log of 2, and then we're going to add 3 to it. So we can type this in our calculators, and we should get approximately 4.766. So now be careful though. Remember the thing we talked about in 3.3 about the parentheses. When you type in that natural log right there, it's going to open one. So after the 3.4, you have to close it. And then you hit divided by. And then when you do the 2, you're going to open it. And then you have to close it. And then you hit the plus 3.